what is divergence and curl. Okay. Okay. See, first see what is divergence. Okay. Remember one thing, multiplication of two vector, or you can say dot product and cross product are valid for when only you have two vectors, right? Okay. So divergence means what? Divergence is dot product with del operator, and both must be vector. This is also a vector, not a scalar function. Okay. You can write divergence phi, right? Divergence means what? Dot product with del operator. And this is also a vector. For example, find the divergence of. Today I will finish the vector differentiation part. Okay. Okay. So find the divergence of vector phi is what? X square I, y square j, x, y, z, k. Okay. At 1, 1, 1. So divergence means what? Divergence vector phi means what? Dot product with del operator. And you know what is del operator? I, dou by dou x, dou by dou y, dou by dou z, dot product vector phi is x square I, y square j, x, y, z. And you know how to find dot product, right? I is multiplied with I term, j with j term, all corresponding element are multiplied, right? Okay. So derivation of x square is 2x, derivation of y square is 2y, derivation of z will be x, right? Yes. And at a point 1, 1, 1 will be 2 plus 2 plus 1, that is 5, right? Okay, understood? So this is divergence. Okay, and very important thing, what? If divergence of any vector phi is equal to 0, then this is called solenoidal. This is very important. What is solenoidal? The divergence of vector phi is 0. Okay, yes. So you can note this. Understood? Okay, now see. Question number. See this. Question number 12. Right? You have to prove that this is a solenoidal. Solenoidal means the divergence of vector v must be 0, right? Yes. So I am writing here question number 12. Vector v is given. Vector v is 2x plus 3y I x minus yj x plus y plus z k is solenoidal. So you know what is solenoidal, right? Solenoidal is nothing but a, yes. Okay. So we will find it solenoidal. Sorry, divergence. If divergence becomes 0, then you can say this is solenoidal. Okay. So divergence of vector v is nothing but dot product with vector v. So I dou by dou x dou by dou y plus k dou by dou z 2x plus 3y x minus yg x plus y plus z k. And you know how to find dot product? Yes. Isn't? Okay. Now tell me, when you do with respect to x, you will get 2. When you do with respect to y, you will get minus 1. And with respect to z is minus 1. So 2 minus 1 is 0. Therefore, you can say vector v here, right, since divergence can be written in capital letter, small letter, doesn't matter. Divergence of vector v is 0, then vector E is solenoid. Understood? No need to write. I will send you the recording. But you understood? Yes. I have seen one more question somewhere. Okay. Only one question is there of solenoid. Okay. Now I tell you what is curl. Any idea about curl? Curl means curl starts with C. C means cross multiplication. Okay. So curl is nothing but curl of vector phi is nothing but cross product with vector phi. Okay. For example, if I ask you, find the curl of vector phi x square I y square j x y k at 0, 1, 2. So you are going to find what curl? Curl means cross product, and you know how to do cross product of vector by using determinant, right? Dou by dou x, dou by dou y, dou by dou z, right? And phi is what? X square y square xy. Okay. When you take this part, you will get what? Dou by dou y xy minus dou by dou z y square, right? When you take this part, this is simply a cross product of two vectors, because this is also a vector and this is also a vector. Okay, first you tell me up to here you understood. Okay. Now when you do with respect to y, you will get only x. With respect to z, there is no z. With respect to x, y. With respect to z, 0. With respect to x, there is no x, 0. And this is 0. So what you are getting? xi, yj plus 0k. And the answer of curl is also always in vector form. Understood? Okay. Now curl at which point? 0, 1, 2. When you put 0, you will get 0i minus j plus 0k. So this is your final answer. Minus j. Understood? Yes. This is curl. And one very important thing, what if curl of any vector phi is 0? Always write zero vector. Don't write only zero, because curl is a cross product and you know the result of cross product is always a vector. So this is a zero vector. Okay. Zero vector means what? 0i, 0j and 0k. At origin you are standing. Understood? If curl of any vector phi is zero vector, then phi is called irrotational. This is very important. In your question, in your exam, directly one question can be asked, what is irrotational? Or sometime you are asked to prove that the function is irrotational. If vector function, or you can say vector function is irrotational, then their curl must be zero vector. Okay. How to prove a vector function is irrotational? Find its curl and its curl becomes zero. Okay. Yes. Noted. Okay. Now see, where is irrotational? Irrotational starts from question number 14. See, question number 14, right? See, read the question number 14. Show that the vector v and vector v. Okay. So there are two vectors given, and both are, you have to prove both are irrotational. So first vector I am taking 9y square minus x square plus y component of I plus x 2y plus 1j. We have to prove this is irrotational. So first I prove this. You know how to prove irrotational? By finding its curl. Curl of vector v. Curl means what? Cross product with vector v. And you know how to find cross product? By using determinant of cross product. Here 9y square minus x square plus y. Component of is this x 2y plus y. There is no component of k, right? Yes. 0 minus x 2y plus 1 minus j. You understand how I am writing this? This is nothing but how, yes, simplification. 9y square minus x square plus 1 plus 1. Okay. Now, when you do with respect to y, it is 0. With respect to z, it is 0. This is 0. This whole term is 0. With respect to x, you will get 2y plus 1. Right. And with respect to y, it is, let me check, 9y square. Okay. Derivation of 9y square is minus 18y minus 1. 0i, 0j. But this is not 0, right? This is not 0 vector. So first v is not irrotational, right? Okay. Now we will check for second v. Second v is what? Exy. This is first part. Why this is not rotation? Because the result is not 0 vector. Okay. Exy, yi plus x. Next is plus 2ez. Now we are going to prove that, we are going to check that this is irrotational or not, right? So I delete this part. Hmm. Find the curl of next vector v. Curl means cross product of vector v. Cross product is nothing but a determinant of curl. Okay. So dou by dou x, dou by dou y, dou by dou z. And what is, when you open the bracket, you will get exy, yi, exy, xj plus 2ezk, right? So tell me what is the component of I, exyi, component of z, exx, and this is 2ez, right? Yes. With respect to y, y is okay. See, with respect to y, there is no y, this is 0. With respect to z, there is no z, this is 0, right? With respect to x, there is no x. With respect to z, there is no z. With respect to x, here x contains in both term. So you have to use u into v rule, right? U v dash plus v u dash. Now in this also use u v rule. So u v dash minus x with respect to x only. Now you can see this term, and this term cancel out. What you are getting? Zero vector. Zero vector means irrotational. Understood? Yes. Now see question number 15. Question number 15 is very good question. Now see, you have to find, right? You have to find ABC. ABC means some constant you have to find for which the function is irrotational. Three x plus ay plus z I 2x minus y plus this is already what? Irrotational, right? Irrotational means their curl is zero. So curl of vector v is already zero. We have to find what? The constant a, b, c. Curl means cross product of vector v is zero. Vector zero. Never write only zero. Write always vector zero. Okay. Because some students are practice in such a way they always used to write only zero. This is vector zero. And what is I component? 3x plus ay plus z. 2x minus y plus dz. X plus cy plus z prime. Right? G dou by dou x plus cy plus z cap is equal to zero vector, right? Now see, when you do with respect to y, you will get c. With respect to z, you will get minus b, right? With respect to x, with 1, and when you do with respect to z, you will get minus 1 plus k. With respect to x2 and with respect to y is minus, right? Is equal to zero vector. Now I'm writing here c minus bi 0j 2 minus ak is equal to zero vector means what? 0i, 0k and 0k, right? Compare the corresponding element. C minus B is 0. This is already 0, no issue. 2 minus A is equal to 0. Right? So from here you are getting A is equal to 2. And from here you are getting B is equal to C. Okay? I check once again. 3x plus 11 equals. Here C and minus B. Okay, correct. So B is equal to C. B and C can be any vector, it doesn't matter. Okay. So A is equal to 2, B and C any real number. But B and C must be equal. Understood? Now give me one. Understood? Okay. So B and C must be equal and any real number. So the effect of B and C does not affect vector V. But A must be 0. Sorry, 2. Okay. Now see this question number 16. See, question number 16 is very interesting question. Vector E and vector H are irrotational. Already this is irrotational given in the question. Then we have to prove that cross product of E and H are is solenoidal. Read the question, then I tell you how to solve this. Okay. Okay. Now I tell you. I tell you again. This is given. Vector E and vector H are irrotational, and you have to prove cross product of vector E cross vector H is solenoidal. Before going to this, I will tell you one formula, and the formula is this is standard formula. Dot product of this is actually a property. So here vector B dot cross product with A and vector A dot cross product with B. This is a one rule. Okay. So with the help of this formula, you can say formula, rule, property, anything you can say, but this will use for solving this. Now tell me, vector is what? Irrotational. If vector E is irrotational, then you can say cross product must be equal to vector 0, right? Yes. Vector E, similarly, If vector H is irrotational, cross product must be zero, right? And what is solenoidal? Suppose this is a vector. Yes. Solenoidal, how to prove solenoidal? Divergence. Okay. If phi is solenoidal, then divergence phi must be equal to zero vector. Sorry, not zero vector, only zero. Divergence means what? Dot product with vector phi is zero. But here phi is what? This is phi, right? So dot product with equal to zero, right? Okay. And you know the by using this formula, here B is what? Vector H, vector E minus. Understood? Put the value of A and B. Dot product. Understood? Now you have already what? This is zero and this is zero, right? Zero. This is not zero, zero vector. Okay. Always remember, whenever you are doing dot product or cross product, write zero in vector form. So this is zero vector. Yeah, okay. Now dot product gives a scalar value zero and zero. Zero minus zero is zero. Understood? Therefore, solenoid. You can go through once this part, then I will go further. Done? Okay, see. Okay, see. Very interesting question. Question number 17. What is question number 17? Uh, Here Laplace equation. Laplace equation and Laplace transform are both different things. Okay. If equation comes, always write right hand side equal to 0. Delta square f is 0. This is Laplace equation. Okay. And you have to prove that gradient f is a vector is both solenoidal and irrotational. So this is given and this is to prove. What you have to prove? That grade f is solenoidal and irrotational. Irrotation. Okay. Right? Okay. Now see, let's suppose uh, f is a scalar quantity, right? It is clearly in the mention f x y z. F is a scalar function. Okay. If f is a scalar function, then grade f must be a vector. Let's suppose vector is vector f, right? Okay. So first we find vector f. Vector f is what? Del f upon del x I, del f upon del y j, del f upon del z k. Understood? Okay. Now we calculate what? Curl of vector f. Curl means cross product of grade f, right? Okay. And you know how to find cross product? I, j, k, dou y dou x, dou y dou y, dou y dou z. And grade f is what? Del f upon del x, del f upon del y, del f upon del z. Right? See, when you take I component, you will get del y by del x, del f, del y, minus del y del z, minus j, del y del x, del f del y, del y del z, del f del x. Right? Del y del x. Let's see. See, this is nothing but what? Del square upon del of yz, right? Del square f upon del zy. Del square f upon del xy. Del square f upon del x del y. Del square f upon del x del y. Every terms are cancelled with each other, right? You are getting vector 0. Vector 0 is what? This was what? Curl is 0. Curl is 0 means this is irrotational. So first part you have proved that you got irrotational. Understood? Okay. Now we will prove that this is solenoidal. Understood? You have to prove both irrotational and solenoidal both, right? Yes. Now I tell you how to find, how to prove solenoidal. Up to here, understood? For irrotational, curl must be zero vector. And for solenoidal, divergence must be zero. Divergence of this means dot product with grade f. How to find dot product? I dou by dou x, j dou by dou y, k dou by dou z. And this is what? Del f upon del xi, del f upon del y. Understood? When you do cross multiplication, you will get this. But you can see none of the terms are cancelled, right? Then how can you say that this is solenoidal? This is not zero. Then how can you say that this is solenoidal? Is this zero? Ah, right. Because in the question, this is Laplace equation. First, I tell you what is this. Del square f means what? Grade of f. Right? Yes. Grade of f is nothing but I del phi by del x. Right? J del f by del y. K del f by del z. When you again take what? This, you will get directly you can write what? Del square f is nothing but understood. And the value of this is what? Zero. Right? So from the given condition, it is zero vector. That's why you can say this is solenoidal. Why solenoidal? Yeah, right here. Since del f square is equal to zero, and del f square is nothing but this is del f square, right? You can write here. That's why this is solenoidal. Understood? Yes. I think you understood solenoidal, irrotational, divergence, and grade, right? Yes. Now I tell you one new concept. This is called scalar potential. Suppose if I give you any scalar function, can you make this into vector function? How? Find the gradient. Now I ask reverse question. If I give you any vector function, can you find a scalar function? No. From the given vector function, when you are going to find a scalar function, this is called scalar potential. Okay. Okay. Finding a scalar function from a given vector function is nothing but a scalar potential. So scalar potential is phi. Finding phi from vector vector function. Okay. How? Use, you have to use this formula. D phi is equal to del phi by del x into dx. This is dx and this is del x. Okay. Del phi by del y dy. Del phi by del z dz. Based on this formula, you can find a scalar function from a given vector function. Okay. Yes. And you know how a vector function is formed by using gradient of f, gradient of phi. So vector phi is nothing but gradient of phi, and gradient of phi is, okay. So whenever a vector is given, write in this form, okay. And after comparing this, put all these value here. I will show with you an example. See, find the scalar potential. Sometimes scalar potential is not written, only potential is given. Okay. Find the scalar potential of x square I, y square z, z square k. Okay. So this is what? A vector function. And you know how a vector was formed by using grad f, right? So vector phi is nothing but x square I, y square z, z square k. And this is what grad phi is what? Understood? When you compare this I component, when you compare, you will get del phi by del x is what? X square. Del phi by del y is y square. Del phi by del z is z square, right? Compare all these element and however find del phi by del x, del phi by del y, and del phi by del z. After getting this, put all these value here, right? Okay, now see, I'm writing here. Okay, right here. Del phi by del x is x square. Del phi by del y is y square dy, and del phi by del z is, okay. But you have to find phi, not d phi. So for removing d phi, what will you do? Integrate on both sides. Yes. X square dx. So left side you will get phi. X square is x cube by 3, y cube by 3, z cube by 3. Always add one constant. This is your scalar function. Understood? Yes. So now when you find the gradient of this, you will get this vector. Understood? Yes. Question number 13 and 14 based on scalar potential, right? See, in question number 13, a vector f is given 2xy plus xi, x square minus yj. First, you have to check whether this is a gradient field. How to check gradient field? If so, find the scalar potential. Okay. So, uh, just start to find its scalar potential. Only potential is written, right? It means you have to find scalar potential. Understood? So let potential function is phi, right? So yes, grade phi is nothing but vector f, right? Okay. So what is vector f? 2xy plus xi, x square yj. Grade phi means what? Always write in this form, right? Okay. Now, why after comparing you will get, isn't? What is component of k? 0. Now, which formula you will use? This standard formula. Okay, right? Now put all these value here. What is d phi by dx? 2x plus x dx. After this, what is your next step? Integration, right? Okay. Sorry, this is not dx, this is phi, right? Okay. So left hand side phi, 2x square. So you will get x square y, x square by 2. With respect to y, x square y minus y square by 2 and plus c. Okay. So whenever any two things repeated, write it only in one time. Final answer will be x square y plus x square minus y square by 2 plus c. Understood? You can check the answer x square y plus x square by 2 minus y square by 2. Yes. Here plus is there. Okay. This is correct answer. Okay. Now can you try to find the scalar potential of question number 14? In question number 14, you have to find a scalar function, right? Find a scalar function f such that vector v is equal to grad f. Okay. So question is not directly asked. Indirectly it is asked. So indirectly means wherever you see potential function, it means you have to find scalar potential. Okay. So vector v is nothing but grad f. And f here f is what? This is scalar function. And try for this. Okay. Tell me what is the vector function, sorry, scalar potential of this. Grad f is what? I. So open the bracket y e x y I x e x j. Okay. After comparing, you will get. Okay. Now use this formula. Understood? Always write in these steps. Systematically write so that you will get all the marks. Right? Okay. After this, do integration with respect to x with respect to y. So 5. When you do with respect to x, in integration, coefficient is divided, right? With respect to y, x will be divided. Now with respect to z, plus one constant. X cancel, y cancel. Final answer is okay. You can write in f form because here f is given. Okay. So name can be anything. I already told you two or three things are repeated, write in only one variable. Exy repeated two times. Okay. Yes. This is your final answer. Now, when you find the gradient of this, you will get same thing. So this is the scalar function and this is the vector function. Understood? Yes. Okay, now can we move? Okay. After this, I will explain some basic question from 1 to 8. Okay. 1 to 6. Not 6, 5.